Any covalent bond involves the sharing of a pair of electrons between atoms. That sharing can either be fair or it can be unfair. If it's fair, we call it nonpolar covalent bonding. If it's unfair, then we call it polar covalent bonding. A famous example of a nonpolar covalent bond is the bond that can exist between carbon and hydrogen. There is a term called electro negativity. And what that really is like saying electron magnet strength. And as it turns out, the electronegativity of carbon and hydrogen are both medium. So they're equally strong electron magnets. And remember, every bond is really a shared pair of valence electrons. Because carbon and hydrogen are similar in electronegativity, that means that neither atom will hog that shared pair of electrons. And so the sharing is fair, and that is considered a nonpolar bond. On the other hand, if you have an oxygen bound to a hydrogen, oxygen is a very great or a strong electron magnet. So we say that it has high electronegativity, whereas hydrogen is medium. So that means that the shared pair of electrons, since oxygen is such a great magnet for those electrons, oxygen will go ahead and hog them. They're still sharing, but the sharing is unfair. The electrons will spend more of their time near the oxygen and less of their time near the hydrogen. So if I eyeball this bond from this side, I will see more negativity, which we say slightly negative, delta negative, than if I were to eyeball this bond on this side. Of course, anytime you hog negative electrons, then what's left behind is slightly more positive. So we call that delta positive. So when you look at this and you see a difference, you see a side of the bond that is slightly negative and a side of the bond that is slightly positive, that should make you think of the Earth, the North Pole and the South Pole. In other words, there's a polarity, there's a difference. And so that's why we call this type of a bond a polar covalent bond.